We'll see Huffman encoding algorithm. So Huffman encoding algorithm is going to give you variable length encoding that is optimal. But how this algorithm works, I will tell you. But finally, your algorithm is going to give you a tree. That tree is going to decide your variable length encoding. We will see that. First of all, in the algorithm, the first step is we have to create trees like this with every key as a node. So here how many keys we have? 4, right? A, B, C, D. What are the frequencies? 70, 25, 5. So with that frequency values, we have to create trees like this. Let's name them so that you can easily imagine them. This is A, this is B, this is C, this is D. But frequencies are important. Once you have 4 trees, now story begins. Your algorithm begins. So in your algorithm, always we pick up 2 trees, any 2 trees, whose frequencies are minimum, and we are going to merge them. So Huffman encoding scheme is all about merging the trees. That's it. So how to merge the trees and which trees we have to select? For that we use greedy choice. That's why this is greedy algorithm. So here first step we have C comma D, because always we have to pick up the trees whose frequencies are minimum. That's it. If you do that first time, what happens? These 2 trees will be selected. So how to merge them, I will tell you. Take a new root and left side you write 1 node, right side you write 1 node, because we have to, and add these frequencies here. That's it. Once you do it, then you end up with this time 3 trees. Again you pick up, always we have to pick up 2 trees with minimum frequencies. Here minimum frequency, if you see 70, 20, 10. Which 2 are minimum? 20 and 10. Now don't consider these 2, only roots to be considered. So 10 and 20. Now you merge them. If you merge them, here one thing, some students ask, sir, should I keep B tree, this tree, left side or right side? Anywhere you can keep. So let me keep at left side, right side, not a problem. So B20. So we are going to merge these 2. When you merge these 2, so this frequency is to be added. 10 plus 20, 30. Now current roots frequency is 30. Now this is another tree whose frequency is 70. Since we have only 2 trees, then we have to merge these 2 in the next step. So it will be 30 plus 70, which is 100. This is going to be your tree, final tree. Understand? So once it is done, we have to stop. Whenever you end up with 1 tree, we have to close the algorithm. Then sir, where is variable length encoding? I will tell you. Once we create a tree, simply traverse the tree and left side you keep 0, right side you keep 1. Then automatically encoding will be done. Here you imagine it as 0 and write as 1. Don't need to write. It is only for our sake. So this is just, whenever you have a left pointer, that will be treated as 0 code, and right pointer will be treated as 1. Now see. So suddenly when you see, now see the coding. So what is the encoding for A? If you want to know, then simply see this tree. This A is left side of root, right? That's why it is 0. We can generate the code. Sir, what is the code for B? Simply descend the tree, you will understand the code. 1, 1. So what is the code for C? That will be 1, 0, 0. So what is the code for D? 1, 0, 1. In that way, so we can understand the code for every letter, right? Now here I would like to discuss some details. Like example, you have 2 frequencies, A comma B. A's frequency 10, B's frequency 10. One of the possibility. Now you thought of merging them at this moment. When we were merging, we have 2 possibilities. Creating a tree like this, 10, 10, 20. Second one, taking A at right side, B at left side, correct? Then you create 2 trees. Which one we have to take? So I said anything is okay, right? But here if you see, based on this left and right, you are going to get a different code, right? Then in this one, example, this is a tree, you get code, for A you get code 0, for B you get code 1. Here you get 0 for B, for A 1, right? Then you get different answer. Which one is correct? Both are correct. So this is one of the scheme, this is another scheme. But what is optimum here is, what is our question? Reducing the message size. Whether you use this encoding or this encoding, like so, by changing the order of the positions, whatever the other encoding you get, everything is correct. All are going to give you optimum solution. Here optimum solution is nothing but the message size will be optimally reduced. Okay, so that's why if you see, so there is an ambiguity, I understand. So whether should I keep a character at left side or right side? you take anything. Example, let's say Raju and Rani are two imaginary characters. Raju got one encoding scheme because of that one selection of order. Rani took another order, left, right. So Raju's left is Rani's right, Rani's left is Raju's right. Then Rani got another combination, but doesn't matter. Both will lead to optimum solution, no problem. So this is about Huffman encoding.